All right, our objective today, we will simplify expressions. We will simplify expressions, specifically monomials. And how many terms is in a monomial? Good. If you said one, you're absolutely correct. All right, so we're going to be using multiplication properties of exponents. Couple of things, okay? As we get into it, like when I show you just like one property, it's going to seem like really easy, right? Because you can just do that one thing. Where it becomes challenging is that by the time I show you like 6 different properties, it's like what to use when, okay? And so I really strongly recommend, let me kind of show you where I put it. I'm going to bring it over here. In your Schoology, I posted it on the bottom, and I put it also in the assessment for tomorrow. But if you have access to a printer, I put it on the very bottom. It's the STAR Algebra 1 reference sheet. And you will have access to this sheet on your STAR exam. It's really important that we learn how to read it, so you know like how that could even be helpful to you, okay? We're going to be focused on this week, and then when you come back from spring break, the properties of exponents, okay? And today, the first one that we're going to be covering is just this one, the product of powers, okay? And tomorrow we'll be doing quotient. Bless you. No problem. And then, go ahead here. All right. Let me go back to where we were at. Okay. So a monomial. Some of y'all said that basically was one term. That's absolutely correct. The official definition is a number, a variable, or a product. And FYI, you will be seeing vocabulary on the next exam of a number and one or more variables. Okay, so the main thing, and I'll show you an example. You could have something like, you could have it 8. That's a number, right? It could be just x. That's a variable. It could be a product of a number and a variable. So it could be 8 times x. You could have exponents, 8x to the second power. You could also have another variable, yes? What you can't have is, and I'm going to write this here, you cannot have a variable in the denominator. And we kind of touched on that last time, right? Okay. And so, for example, my counter example would be something like 8 over y to the third power, right? You cannot have that variable of y in the denominator at all, ever. Okay. And then finally, our last vocabulary term, a constant. That's a monomial. That is a real number. And there are imaginary numbers, and you may get to that next year. Okay, so basically a real number is, it could be like 3 over 2, it could be negative tens, it can be fractions, it can be negatives, it can be a decimal. It also could be a square root. We'll get into that. Okay. Any questions? We're okay? Awesome. All right, so example one, we want to determine whether or not each one is a monomial y or y not. So basically, I want you to type in the chat which one is not a monomial, okay? And FYI, like let's say you were trying to type in that F2, when you type it in and you don't have access to a math editor, just know that you can always type it in like this, F with a caret, that's shift 6, and then 2. And that basically means the same thing, okay? So I'm gonna go ahead and give you a second, okay? So again, it's okay to have a fraction. This one is okay. Yes, it is a monomial. Okay, but this one is not. Okay, and the reason being is because of the variable in the denominator, right? This has just a 4, and that's fine, okay? But it's not a monomial because of the variable in the denominator. And most people didn't really select these two, so these are all yeses. Oh, wait. This one is not a monomial. Who can tell me why? I almost fell for it too. So this one, yes, is a monomial. Okay, you got numbers, you got variables, you got exponents, all good, right? And it's 2. This is actually a binomial, right? Because what separates the terms? It's the pluses and the minuses, right? Yeah, exactly. And so right here, that separates it. My first term is 17. My second term is negative c. So this is actually a binomial because there are 2 terms. So I'm going to put that in there. Because there are 2 terms. Pretty easy? Hopefully. All right, questions. Let's move on. All right, example 2a. So this is how you do it, okay? And if, let's just real quick, I'm going to flip back to that little thing right here. Right here, product of powers. Notice that we have a to the power of m, a to the power of n. And what do we do with our exponents when they're like that? We add them. Can y'all see that okay? Do you need it larger? Anybody need it larger? Yes? Okay. Let's see what I can do. Let's see. Control like that. And there we go, okay? A to the power of m, a to the power of n. So each one has its own base, okay? This is called an exponent, the little m, the little number up top. And whatever it's kind of referring to, that's its base. Thank you, sir. I appreciate it. And so basically, when each exponent has its own base, then we add. Okay, so I'm going to go ahead and write that down over here. Sorry. Go back over here. So the rule was a to the power of m, a to the power of n is equal to a to the power of m plus n. Okay? So for example, because living in the abstract sometimes is challenging for people, if I had x to the 5th, right, and x to the 2nd, each one of them has its own base, right? Each little exponent has its own base. All I'm going to do is say x to the power of 7, okay? And the reason being is, what's another way of saying x squared? Anybody? Okay, so this was from middle school, okay? And if you had x squared, that's just the same as saying x times x, right? 2 times. The exponent tells you how many times, right? And then with x to the 5th time, to the power of 5, basically you're going to write it 5 times. Let's see if I can squeeze it in. Okay? Cool. Thank you, sir. And so what we do is we just count 1, 2, 3, 4, 5, 6, 7. And I write x to the 7th power. Does that make sense? How it's the same thing, except that every time we don't want to have to like write it all the way out. We want to work smarter and not harder. And we just simply know that we can actually add the exponents. We can say 5 plus 2. Okay? All right. So let's go ahead and let's do this. I will tell you, I have the tendency, I like to put my variables in alphabetical order, and I like to put my constants up front. Here, everything is multiplying, right? So this is the same as r to the 4th power times maybe negative 12 times r to the 7th, right? I like to put my constants up front. Doesn't really matter what order we multiply in. I'm going to bring the little negative with it. R and R. I got r to the 4th and r to the 7th. Are y'all okay with how I rewrote that? Make sense? Okay. So now I have the situation just like we had here, right? And I'm going to go ahead. I got 12 times r, and I'm going to add my exponents, 4 plus 7. Okay? And that is equal to negative 12 r to the 11th power. Any questions? Okay. All right. So example 2b, your turn. Okay. I want you to rewrite it so that you have your constants up front. And I want to point out one thing. Whenever you don't have a variable on top of, you have a variable without an exponent, you want to just put in the little ninja 1 right there. Okay. He's there. You just don't see him. So I'm going to go ahead and pause the video. If you're watching it, do it, and then come back. All right, so we have 6 times 5. Okay. Everything here is being multiplied, right? Okay. And then I have my c to the 1st power times c to the 5th power times d. See where I'm pulling it from, right? And I got d to the 5th times d to the 7th, right? So I want to point this out. When I get done with this right here, what do you think I'm going to have? 11 or 30?
30.
Yes, because we're multiplying. Everybody kind of gets caught up with the whole, I'm just adding. Numbers are normal. Remember that, 6 times 5 is the same as 6 times 5 has been since you were hopefully in 3rd grade learning how to multiply, okay? And, oh, did I make a mistake? Yes. D to the 2nd power. Thank you. I appreciate that. Okay, so 6 times, that's absolutely going to be 30. So remember, the numbers in the front, your coefficients in the front are normal, okay? So go ahead, tell me the rest, and then type it into the chat. I'll give you another second. So what happens is we each have this right here has its own base of C. And the bases have to be the same, right? So this is going to be 1 plus 5. So that is 1 plus 5. I'm going to put it here. I'm putting it so that if you're like using it for homework or you're using it for an exam, you can actually see and figure out what you did. And here you had 5 plus 2. So that's going to be 5 plus 2. And so when you write it, it's going to be 30 C to the 6th power D to the 7th. Those of you who made some mistakes, do you see what you did wrong? Okay. And we are not going to combine the 6 and the 7 because the bases are not the same. I hope that part's clear. Yes? Okay. So without multiplying signs. Okay, I don't really see any negatives or positives, but essentially all we're doing is we're taking the exponents with the same base and we're adding them 1 plus 5 and you get 6. And then here we have 2 D's, right? 5 plus 2, that's 7. And then here, this is just 6 times 5. There was no negative or positive. I hope that's okay. Good. Just want to make sure. All right. So ladies and gentlemen, this is the answer to this one. Okay. All right. Any other questions? No, don't apologize for asking a question. All right, I do want to go ahead and show you one last thing. If I have, let's say I have a square. I'm going to do my best to make it nice looking. And you know what? Actually, I'm going to make it a rectangle. Real quick in the chat, go ahead and refresh my brain. What is the formula for area of a rectangle? This is one of those things that you will notice is not on the algebra star sheet, but they will ask you questions. And they expect you to know what it is. Very nice, ladies and gentlemen. It is length times width, or if you said base times length, you get the idea. It's basically this side times this side, right? So if we're going to figure out the area, I'm going to go with the length times width. And the area of this is going to be 10x squared, y to the third, times 5x. All right, ladies and gentlemen, I'm going to go ahead and put this on pause, but I want you to tell me what is the area of this rectangle. Please do not forget to put in your Ninja 1 whenever you have a variable without an exponent, because I guarantee you'll forget it, right? So let's go ahead. We're going to reorganize this. I'm going to put my coefficients up front, and I love that nobody said 15 this time, right? And then we're going to put our x's. I'm just going in alphabetical order. And then I got x to the first. And then I have y to the third. And so when I do this, remember that numbers are normal. 10 times 5 is just 50. Here I have x to the second power plus 1, right? And then times y to the third. So this is just going to end up being 50 x to the third power y to the third, aka cubed. Okay? Questions on this? All right, ladies and gentlemen, I'm going to go ahead here and sign off for those of you at home. For those of you who are